Good afternoon, everyone. I hope everybody is doing well. So let us continue with the finalized chapter of 9 that is related to the interest rate risk. And that we used to go through the end of chapter questions. So we'll proceed with this because we have got many questions are given here that we have to solve it. Okay, let me share the screen with you then. So in here, suppose I'm going through question 16, okay? Question 16. Suppose you purchase a 5-year 15% coupon bond that is paid annually, which is priced to the yield of 9%. So YTM is equal to 9%. And the face value of the bond is always as 1,000. So with the first calculation, it asks to calculate the duration of the bond of equal to 4 years. So we need to construct of 4 years of calculation that will bring us, is it 4? It's 5. I'm sorry, misread. It's 5 years. It's 5 years. So here. So we do the same thing. T, I'm going to be very quick. Cash flow. T, cash flow, discounted cash flow. And times the period time is multiplied by discounted cash flow, but it's not actually the timing, it's just reviewing as periods, like how many periods we have. It can be frequency of payments, we can say correctly. So 1, 2, 3, 4, and 5. And the cash flow we're going to receive fixed, and these things, all the stuff we needed just to calculate. We needed this to calculate the duration, okay? Okay. Now, the cash flow is given here, 15% of coupon bond, and the coupon payment, and the cash flow is calculated like coupon rate times the face value. This is what we know. It's 150, 150, 150 for each year, 150 for each year, plus here 1,000 plus 150. What we know it's 1,050. This we know how to calculate it. And discounted cash flow, we need to just discount this cash flow to get calculated discounted value. So we get this 150 divided by 1. The discount rate, or YTM, is 9%, 1.09 to the power of 1, because we're going to get it to the year 0. Okay, this is the discounted cash flow. If we drag it down, we should get all discounted cash flow here, okay? Now, the last step, what we do, we just multiply with the period, the discounted cash flow. And we just make it down, okay? So you have the last 2 columns, you have to get the summation of it, okay? Each column should be summed in order to get proceeded with the calculation of the duration. So as you sum it, okay, and duration is equal to this divided by this, and it's 3.97, which is not dollars, but is in terms of years, okay? It's just a number that measures in terms of years, so 3.97 years. So this is what we've been looking for. Approximately it's 4 years, okay? It's 4 years, but let's leave it as 3.97. So this is how we calculate it. So this is part A, question 16. Is it 16? Yes, question 16, part A. Show that if interest rate rise to 10% within the next year, and your investment horizon is 4 years from today, you will still earn a 9% of yield on your investment. Now you need to change bit. So how everything is going to be affected in here. You have to show what will happen to the future value of your investment in general case, okay? So first of all, we need to calculate, we need to get 4 things into consideration when we calculate the total value of your future investment. First, we need to calculate the bond value, okay? The bond value. So we know bond value, there's a big formulation we can calculate using the scientific calculator, or we can use the Excel spreadsheet to go over it, okay? So rates, let me proceed with the rates. So let me give you the coupon rate. Coupon rate is equal to 0.15, and YTM is 0.09, which is 9%. Face value is 1,000, and coupon payment is like face value times rate, like, which is 150. Okay, this is what we have it, face value, coupon payment, and these are the rates. Okay, this all informations are given. Now we are looking for the total value of the future investment. The first thing that we should start is calculate the bond value. But it should be considered at the end of the year 4, which means that when you consider the bond value at the end of the year 4, that, and our bond value, bond is actually 5 years old, and that means that it's going to be matured in 5 years, that we are trying to resell it in the year 4, end of the year 4 and the beginning of the year 5. So 1 year will be remaining. So we will take into consideration just 4 years, not so in here, show what if interest rate increases to 10% within the next year, and your investment horizon is 4 years from today, and you will still earn 9% yield on your investment. So let us calculate how it works. So we'll do just present value. The rate is 10%.
Isn't it 9?
Sorry?
Isn't it 9 rate?
No, not 9% here. It should be 10%. Because it's increased. In part B, it says, if you read the question here, it says that it, here, show that if interest rate increases to 10%, okay? Now it's 10% within the next year, and your investment horizon is 4 years from today. That means that you will sell your bond at year 4 and still earn 9% on yield on your investment. We want to compare how much you're gonna make the money on this, okay? So we want to actually here to compute the bond value, more specifically, bond value at the end of the year 4. This is what we are trying to find out. So 150 plus the $150 that we received in year 4 plus 1,000 when we sell it, we receive the face value on it, okay? And this should be discounted by 1.10. Because from year 5 to the year 4, there is 1 year. So we are raising just to the power of 1. This is what we get it as the bond value at the end of the year 4. And now we need to calculate the future value interest payments. In general, you're going to receive $150 every year, but for 4 years, with the interest is 10%. So we need to get the future value of it, how much you're going to receive in terms of interest, okay? In total, how much you're going to receive if it's compounded. So future value of interest payments, like interest on interest, because whatever you receive 150, you're just reinvesting it, okay, at YTM rate. YTM rate became 0.10, which is 10%. It increases, okay? This is what it means. So future value of interest payment, that will make you, so $150 times 1.10 the power of 4. I'm sorry. $150 every year times 1.10 to the power 4. Just a second. Why does 150 future? Let me do it in the formula, okay, formulation. So the rate is 10%. Number of period is 4. For payment, we're gonna have $150. Okay, and the present value in here, we assuming that it's 0. Yes. And I put minus sign here so that we don't. So this is what we get, future value investment. So that means, this number means, guys, that when we receive $150 as coupon payments, as coupons, we reinvest them at 10%. Professor, the real world, when calculating value of the bond, which interest is used, discrete or continuous? Actually, when you in the real market, when you calculate the it directly gives you the calculation of the YTM in the bond market, okay? If you check the bond market directly, you will see that they give you the YTM, they give you the coupon rate, and from that, and they give you calculated the bond value at that year as well. So they give you directly. So for your case, it depends when you would like to sell this bond. So what is your investment horizon, okay? If you said that I'm gonna sell it at year 4, then this is the case that you should take. So you should consider the interest rate at that year. So we are assuming that the interest rate will increase by 1%, it will be 10%. This is our assumption, but when it comes to the reality, it might be totally different, okay? It's just expectation. Now, we calculated this, how much we gonna get when we receive 150 as coupons, and then we reinvest them. And the last stage, what we do here, we should come up with the value of the bond in the year of 4. So we calculated is, which is $1,045, and the coupon interest payments basically. So let's get things make it clear here. So first of all, when you receive the coupons, your coupons are equal to $600, okay? You're receiving them over the 4 years, which is every year $150. That will make you in total $600. And what is next that you're earning in here is interest on interest, like compounding effect, okay? And this is the case. How we can get this calculated is 696 minus your fixed amount of the payment. So this is much you earn actually on your interest on interest when you reinvest it. And the value of the bond at the end of the year 4, so the bond value that we calculated is equal to this amount, and let me type it here. So total future value of investment. Total future value of investment. This is how we calculate. When you decide to resell your bond at the end of the year 4. Okay, let's proceed with the question. Show that 9% of yield also will be earned if interest rate fall the next year to 8%. So what will happen if the same thing happens, if it is like not increase the interest, but it reduced to 8%? What will be the total future value? So same condition should be here. Okay. So we will change the interest rate only to not 10%, that it will be only 8%, okay? That will change the total future value of interest. And this will be 0.8. So if in here, the bond value, look what happens. There are two effects takes the place, okay? Two effects that takes the place. First of all, interest rate changes, it affects the bond value. The bond value, there is an inverse relationship between the bond value and the interest rate. As interest goes up, the bond value falls down. As the interest goes down, the bond value increases. So in this case, the interest rate fallen down, the bond value appreciated first. However, the earnings, the reinvestment part is taking the opposite direction. So when the interest is falling down, that means that you will earn less money on reinvested coupons, okay? That will be better. However, the effect on the change in the value, the effect on the change in the bond value is less than the effect on interest on interest. That will reduce your total future value investment. Our total future value of investment going down. Although, as interest rate falls, that increases our bond value by some point, okay? Increase our bond value to 1,064, okay? But it reduces the earnings on interest, on reinvestment. So that means that overall, total future value of investment falls because the effect of decrease in interest, effect of decrease in reinvestment is higher than increase in bond value. Okay, just let me make it smaller. So this is the case.
Professor,
Yes, please.
may I ask, in that comment, we reinvest $150 coupon at 9%, right? In the last case.
No. We reinvest at 10%, but we're reinvesting at 10%. But in the last case, we are reinvesting at 8%. Okay. We are reinvesting. Sorry, I didn't recorrect it here. We are reinvesting at 9% here. Okay. Sorry, at 8. It was 9, increased to 10. Then it was 9. It decreased to 8.
Okay.
Okay. Now let us go further. Question 17, it's related to 16, but I will skip it. I will directly proceed to the question, very big question, which is 18. It's good and very big question as well. Okay, this question 18. So I'm going to go over question 18. Now, let's make the things clear here. We have two banks, okay? Bank A and Bank B. These two banks are being examined by the regulators to determine the interest rate sensitivity of their balance sheets. Bank A has the assets composed solely of 10-year, 1 million loan with the coupon rate and yield of 12%. So the loan is financed with a 10-year, 1 million CD with a coupon rate and a yield of 10%. Okay. So let's put the things into Excel. So to see the picture of the balance sheet of this Bank A more clearly. Okay. We have Bank A. Bank A. So the Bank A has assets. Let me just highlight it and make it all so that it can be filled. So we have loan and we have CD. Loans are the asset and CDs are the liability. So that means we have gathered the liability part as a CD, certificate of deposit. We collected the deposit and we provided loan. So the information says that the loans are, let's start with the CD because the initial stage was the CD, because the CD we collect and then we give a loan. So we call the value of the CD was 1 million, and that means that 1 million is, so value, so was 1 million. 1 million here. So we collected deposit of 1 million and we gave these loans as 1 million. This is what we know. Then coupon rate, YTM, or interest rate, we can call it. The yield is 12%. The interest rate, coupon rate is 12% as well for the loan that you provide. So when you sell this collected money to the investors, you sell it at 12% of coupon rate and 12% of yield to maturity or interest rate. But when you collected this 10-year 1 million in value, the CD coupon rate was 10, okay? So let me call it not YTM, just interest rate or yield. So coupon rate, it is 0.10, 0.10, 0.12, 0.12. The maturity, I'm just putting the name, M, the number of period is 10 years and 10 years. Okay, this is 10, make it. So in here, we make a profit of 2%, okay? This is the profit we make actually. So what else the information is given? And there is a bank B, has the asset composed solely of 7-year, 12% zero coupon bond with a current market value of 894,000 and the maturity, the principal of 1,970,000. The bond is financed with a 10-year at 8.275% coupon of the face value, and the CDs yield to maturity of the 10% with a loan of CDs that pay interest annually with a principal due to the maturity. Okay, so let's record the information related to bank. So this is bank A information. And let me just copy it. I may need it, some of the variables here. And bank B, the bank B says you have 7-year, 12% zero coupon bond. That means your coupon bond with the current market value is so here with 0%. Here we have 7 years, but we provide these bonds with a 12%. It's same, okay? We provide the bonds with the same percentage. When we give as a loan, we charge 12% the same, but zero coupon bond, there is a zero coupon payment, that means, and the value of that bond, coupon bond is 894,000. 894,000.20. Okay, this is, we have the value of the loan that we provide, and the principal value at maturity, the principal value. So we have additional information here. Principal value, which is given here, 1,976, 1,976, 362.88. And this is the rate. And it is being, the bond is actually is financed at coupon rate. The bond is being financed at coupon rate 8.2725. So we finance this type of loan with the bonds with a coupon rate, with the CD, actually it's a CD as well, certificate of deposit, with a 8.275%. Okay, let me make it more clear. It's not an 8, just increase numbers. And the yield to maturity on this is 10%, and the number of the years is 10 years. So the loan and the CD pay interest annually. So both. This is the information we have it here. So two banks, okay? Now we can see the picture of the balance sheet of two banks, how they work with. Okay, good. So we proceed. Why did I put here bank A? Now two banks are here, then we need to move to question itself, what the question is asked from us. Here, the question is here. If market interest rate increases by 100 basis, how do the market value of this asset and liability of each bank change? That is, what will be the net effect on the market value of the equity for each bank? It's a good question. So let's see how each bank's balance sheet value will change as 1% increase in the interest rate and how it will affect the market value of each bank, okay? So let us start with the bank A calculation. We have bank A. So an increase of 1% in interest rate will cause the market value of balance sheet to decrease. I will explain you why now. With the calculation, first let me calculate and I'll go over again. Now, first of all, we need to calculate what will happen to the loan, and we have CD. So what happens to the value of the loan? In here, we need to calculate, we're calculating for the bank A, okay? Bank A. While we are calculating the loan, what will happen to the value of the loan once the interest? So we're just calculating the interest. So first of all, it increases by 1%. That means this yield will be increased by 1%. So what happens to the loan? So when we calculate the loan, we're calculating for bank A, it was 12%. Now it will be 13% because it increased to 13. And the number of the years is 10. The payment is coupon payment is 12% times face value, the value of it, which is 1,000. And the face value is the same, by the way, and because the value, when the coupon rate and the yield is the same, the face value is equal to the bond value or the loan value. This is what you should keep in your mind. And we close the brackets. So, and my future value is 1,000. Oops. Face value is this. Okay, this is my bond value, but it's actually not negative. Okay, I'll put it like this. And before the changes, the bond value was 1 million. The loan, the value of the loan was 1 million before any changes. It was 1 million. Now it becomes this much. The CD, before it changes in interest, it was this. Now we'll see how much it will be then. So present value 0.13. Number of period is 10. Payment is coupon rate times 1 million. So this times this, like I mean measuring the coupon payment, and the face value is 1 million. And we're closing the bracket. But I made a big mistake here. It's not 13. Who can tell me what is the interest rate in here? It's when it's CD?
11%.
11%. Yes, thank you so much. 941, and it's still giving me negative, but I forgot to put negative sign. Okay. Now, this is what I found it here. So the loan value decreases by how much? So 1 minus this. So I think it's ending minus beginning. That makes more sense. Ending minus beginning. That will show by how much there is a reduction. If ending minus beginning. This is by how much it's deteriorated, okay? And that deterioration shows that how much. So now we can calculate what will be the value of the assets. So let us see. How can we make it? If you add, if you subtract, like, how can we find the change? We actually, in order to find the equity, I mean, change in value, well, it's a basic formula. Everybody knows this, like equation, asset minus liability, okay? Our asset is the loan and our liabilities is the CD. Now, this minus this, and this will show by how much our equity is changing, okay? Here we go. Here we go. So for bank A, the equity changes, the value of the bank changes by positive. And the reason is that the decrease in assets due to the changes in interest is less than decrease in liabilities. That makes equity to increase. Let me type it. Decrease in assets is less than in liabilities. As interest rate increase. Thus, it leads to a positive change in the value of bank A. So this is for bank A. So what happens to bank B? So for the bank B, we're doing the same thing. So this is bank B. And in bank B, we have bonds provided and CD. Now, let's see what happens in bank B. So in bank B, if we calculate the present value, so PV is equal to, the rate is actually in bank B as provided loan, it is 12% and it becomes still 13%, 1% increase. The number of the period in bank B is 7. In bank B, do we have any value? Do we have anything like coupon payments in here? No, that means we don't have any coupon payments. That means that we don't have any payments, which is 0. And our value in bonds at the end of the maturity is 1 million, the principal value, okay, this one. Okay, it's still negative shows. Why? Because we used present value. That's why we need to put a negative sign. Okay, now, and my value is here. Oops, what I'm doing. Wait. Okay. Same thing in here. Who can tell me what is the interest rate for CD? Same or we need to change?
11%.
Please. Look at the CD of the second bank. Look at the CD of the second bank interest rate is 11%. And what else? The number of period is 10. And the payment is? Who can tell
1
me?
million multiplied by 8.27%.
Very good, very good. And our face value is?
1 million.
1 million. Perfect. And just a second. In here, I have some mistake. I have to find it out, the calculation of this value. The value of it, I need to find out. Here, I need to calculate the bond value, okay? What I do here, just a second. So let me calculate here. There's something wrong with this, present value. So it's not, in here we don't put the face value, we put the market value. So we put the value of it. So rate is 10%. This times this. Sorry. It's 10, this, okay. And the face value is 1 million here. We close the bracket. Okay, this is what we get it. Yes, that makes more sense actually. So the current market value with this rate, without any changes, it will be equal to this. Then I use this rate, okay? Okay, that makes, that sounds better. And let me read the question. This is for the part B, bank B. Let me read it again, the question. So 12% zero coupon bond with the current market value of 980. So we have bank B has the asset composed of solely 7-year, 12% zero coupon bond. The bond with the current market value of 894,020, okay, with the maturity principal value of this, okay. The bond is financed with a 10-year and 8.275% coupon payment with a face value of CD. 1 million of face value, and the yield to maturity is 10%. Okay. 10%, 10-year. Okay. What else? We used all the numbers, and we get this. And this is the bond value, which is for 12% yield with a 0 coupon bond and 7M. Okay.
So we have the same values for the loan and for the CD.
No, 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 no. They are not the same. They are not the same, guys. They are not the same. They are not the same. They are not the same. Okay, here we go.
Ah, okay.
It's just by coincidence they matched. Okay, the first before the decimal numbers, they matched. They matched. Okay, then we have here. We can see that 8. This is the value we receive it, and this is the value we have actually. Okay. And this is the value we generate using this. Now, and equity will change. Same thing here, okay? But the equity will change by a small number than if you compare with this, because what we can see, so the explanation is the same thing. So decreasing the asset is less than the liabilities as interest rate increases, as it leads to a positive change in the value of bank B. However, the bank B has smaller effects. Here's a question. What do you mean by 11, Bekjan?
That was an answer for the CD, certificate of deposit yield, when you asked by how much will change it.
And by 11% it will change, you mean? Okay, I got you. I got you. Thank you. Now, let us move to, this is part A, okay? This is part A. This is part A. We just compared how much each bank changes. So now we are, as a regulators, put yourself to the shoes regulators and try to see the difference in here, guys. I don't want you to just make a calculation and give the results and quick decision. No, in here you have to pay attention to the balance sheet. What's going on? Your job is to find the sensitivity of the asset to the interest rate changes, okay? This is your job as a regulator. Who is more sensitive to changes in interest? So who can tell me which bank is more sensitive to 1% change in interest?
I think bank A, because it has higher change in equity, in value.
Yeah, very good. So that makes you to think about the banks very carefully, because if you would want to invest, you should be very careful. You would invest to the more stable bank. So a small changes in the equity by the changes in the interest rate, it indicates that this bank is more stable than this bank. Because why? If the interest rate falls, that really will reduce. We'll come to that point. We'll come to that point. That will reduce the effect on the value of the interest. That will reduce the change in the equity. So we should be very careful about it, about the changes in the interest. So we are looking for the banks who are less sensitive. As we said at the beginning of the chapter, when we started to talk about the interest rate risk, the best position of the bank is to immunize their balance sheet. What do I mean by immunization of the balance sheet, guys? Who can tell me? What is the immunization?
Decreasing the sensitivity to interest rates.
It's minimizing the gap.
Yeah, it's a minimization of the gap, which is you're trying to make your gap is equal to 0. This is your job as a bank. So we can say who has succeeded in this strategy, Bank A or Bank B? Like who was very close to successfulness of immunization their balance sheet?
Bank B.
Bank B, yes. That means their interest rate risk management strategy works better than interest rate strategy than Bank A, okay? Please try to keep this explanation in your mind, okay? You will be, when in your exam, when you will be given a question, I will not only ask to just give the calculation a small explanation. I want you to think and to imagine and to put yourself to the regulators, to put yourself to the potential investors, and to come up with a really good explanation. Okay, think a bit critically. Okay, this is part A. Let's go for part B. The part B is a theoretical one. What accounts for differences in the changes in the market value of equity between two banks? So the asset and liabilities of Bank A change in value by different amounts. This is, we underline it. And because of the duration of the assets and liabilities are not the same in Bank A, even though the face value of the maturities are the same. So for Bank B, the maturity of the assets and liabilities are different, but the current market value and the durations are the same. So that change in the interest rate will cause a smaller change value for both liabilities and assets, actually. Okay, that makes the bank to be less sensitive as well. So apart from the thing that we underline, actually what we were trying to say, that they're using duration gap is close to 0. That shows that why it's close to 0, because their duration is exactly the same. Okay, it's 7 and 7. So how it works, theoretically we explained it, but now is the turn to go to clarify or to verify our explanation by number. Okay, so far what we have been trying to explain, so far what we have been trying to give, we were doing all the stuff, all this explanation by theoretical. Now is the time to verify our explanation. So the part C, it asks you, please verify your results above by calculating the duration for the assets and liabilities for each bank. Estimate changes in value for expected changes in interest rate. So we need to summarize our results. Part C. So part B is whatever we explained, like concerning the immunization, and the video is recorded. If you would like to listen again, you can go and try to re-listen again. You are welcome. It will be uploaded to YouTube, and it will be available from your Moodle as well. You can re-listen the explanation as well for part B. And part C, now is the turn to verify our calculation. Let's start from the Bank B then. So Bank B, it's time to go with a CD. We start with our financing. So we are trying to calculate the sensitivity, how they're sensitive using the duration, but so timing, cash flow, discounted cash flow, and time T times discounted cash flows. Okay, for timing, we have 10 years for CDs. Okay, Bank B with CD case. And our cash flow is 8.275%, which is 82 and 75. It is paid annually. So we're dragging until here. At the end, we're gonna put the face value 1,000 plus the interest paid. So this is what we get it. And if you wanted to discount it, you will discount at 10%. We assume it doesn't change. So this divided by 1.10 to the power of 1, and we just drag it down. And if you just get the time multiplied by period of time multiplied by discount cash flow, this is what we get it. And summation so my duration is equal to this divided by this number, which is 7 years, exactly 7 years. This is for CD, and bank with B with bonds, 0 coupon bonds, bond with a 0 coupon bonds. The duration is 7 years as well. So the white 7 years, because duration of 0 coupon bond is exactly equal to the maturity of the 7 years. So if you go and see what was the maturity of that bond, even if you try to calculate, you will come up with the 7, okay? So just keep in mind. Let me write the explanation for you to keep in mind. So duration of 0 coupon bonds is the same with its maturity. So if the maturity 10 years, your duration for the 0 coupon bond will be now, okay, we calculated duration. Now, let's use to calculate the change in value. Change in value. Change in value is equal to, if you remember the formula, it was minus duration times relative change in interest. Relative change in interest. So it was the following formula. It was change in interest. Change in interest divided by 1 plus interest. This is the formula we have it. And this all should be multiplied by price of the certain security, price of the, like current market value, price. This is how we get it. So that means changing value that will calculate, let me calculate it here. Minus 7 times our interest rate change by 1% divided by 1 plus 12, 0.12. And this all times by the value of that bond, which is this. Okay. I think I'm liking the time. The time is over. Okay, let me stop here. Tomorrow I will continue. I will make a quick revision of the last part of what I did it and we'll proceed. So, okay.
So can I ask a question?
Yes, please. Sure.
So I think that the duration we are talking about now is called Macaulay's duration. And there is another duration that's called modified duration. And so in the book by Fabozzi, Fixed Income Analysis, he says that the modified duration is the better approximation for the price volatility of bonds. So do you have any information about it?
That's very true. So this duration is called very true that we're trying to see if you remember from the slides, if you go back now, what the formula we used it is, I will show you again to remind you. Oops, I'm open this first interest rate risk. The formula that we were using is this one, okay? We were trying to get the sensitivity. And this is the duration that is calculated here. We call it like a weighted average of duration, okay? This is, we explained it already. But in here, the duration we're trying to do is a normal duration is what we do in the normal duration. But what you said when it comes to the modified duration, we'll come to that point, okay? We'll have many questions. I will introduce those things to you as well. But this is just simple duration that we're using in here. The duration that you're taught to calculate, but we have got another different duration. I'm gonna teach that duration as well. So basically, we were trying to measure the price sensitivity, like changes in interest rate, how the changes in the value of for specific banks. There's one person who raised their hand. I just missed the name. Any questions? Yes, don't worry, I'm here. I will wait until everybody leaves and we can talk, no problem. If you don't have any questions, thank you very much.